All right, looking at example 4, they ask us to rewrite the quadratic in standard form and give the vertex. And remember, when they're saying standard form, they're saying what I've always thought of as the vertex form. Now, the thing that I want you to remember from your previous algebra class is, in order to get a squaring, we have to do something called completing the square. And what we're doing is we're aiming at a, don't write this, we're aiming at a quadratic, and here's a pretty simple one, that can be rewritten as a perfect square. That's why it's called a perfect square quadratic. So everything depends on B. As long as C is B divided by 2 squared, this will always work. So when we complete the square, we use this formula. The thing we have to add to make any quadratic a perfect square is b over 2 all squared. Now, a couple of things we have to know, a couple of things we have to keep in mind. A has to be equal to 1 every time. So often that if we have to divide to get a equal 1, that'll result in fraction work, but that's all right. And the other thing we do is we just completely ignore the C that we were given. So I'm going to start this problem by subtracting 1 from both sides. And I'm skipping a step here. I'm supposed to just write f of x equals 0. So we're going to assume it's 0, and we get negative 1 equals x squared minus 6x plus 1. Sorry, not plus 1. We got rid of that. So now all we're looking at is the right side of our equation. And we are going to do our substitution for b in our formula. We'll get a negative 3 squared, and ultimately we'll get a positive 9. So we're going to just add 9 to both sides. And simplify. And now we can take the right-hand side and we're going to just write it as x minus 3 squared. If you're not sure what to put in your binomial, you'll find it in the middle of your calculation for the thing we have to add. So I'm going to do a couple things in this one step because I'm pretty much running out of room. I'm going to subtract 8, and it'll show up, not going to put it with my trinomial, because I'm going to write my trinomial as, so we get a 0 on the left-hand side, I'm going to write my trinomial as x minus 3 all squared minus 8. That's where my 8 went. And last thing I'm going to do is just replace it, the 0, with my function notation. So I start out with f of x. And we are done there. And our vertex, it looks like it's at 3 and 8. Okay, I promise to speed up on the next example. I just felt like that was worth explaining, so to jog your memory, because you have done this before. Okay, we're going to get a 0 on the left-hand side, and we're going to get rid of c. We're just going to move it over to the left-hand side so that we can think. All right, now the one thing you want to watch out for with this one is that we're going to have to divide everything by negative 1, or I'll go ahead and multiply by negative 1, same. And the reason is I don't have a positive 1 in front of x squared, so we always have to fix that. Now keep in mind though, we're going to come back, because if you look at our original quadratic, it's going to be opening down. So we can't just, whenever we multiply or divide to get to a equals 1, we always have to multiply back in what we took out. Otherwise, our problem won't be equal to what we started with. All right, so calculating, my b is 4. I'm calculating what I have to add to make it a perfect square trinomial. I get 2 squared, which is 4. So I'm going to add 4 to both sides. I get 9 equals, okay, so x squared plus 4x plus 4, I can just write as x plus 2 all squared. So I'm going to subtract the 9. And I'm also going to multiply everything by -1 to make sure that this has the same size and shape and orientation as my original. So we're basically watching out for A. All right, 0 times anything is 0. I'm just going to go ahead and put my function notation back in there. Negative x plus 2 all squared plus 9. And that's our equation. Our vertex, it looks like it's at -2 and +9. Now keep in mind that the multiplier A, if it's negative, it doesn't affect our left-right translation. All right, I'm going to